All right, let's get right into it. We're going to talk about a powerful new scientific method, one that's being used to tackle two problems that seem worlds apart: curing cancer and analyzing completely unknown mysterious materials. It's a fascinating story about data, deception, and, you guessed it, an AI that acts like a scientist in a box. So, to really get a sense of the first problem, cancer, just listen to this quote from Dr. Garry Nolan at Stanford. He says, "Every day, you'll develop 5 cancer-like objects inside of your body." Think about that. 5. Every single day. So the real question is, how in the world does our body keep up? Well, it turns out our body wins that fight almost every time. But it's not a simple battle. It's more like a deceptive dance. It's a story of information warfare, where one of our own cells learns to lie, cheat, and trick the very system that's designed to protect us.
I love how Dr. Nolan thinks about this. He sees cancer not as some kind of advanced evolution, but as a devolution. It's like a cell that breaks its social contract with the rest of the body. It just forgets its job and reverts back to this ancient primitive instinct to do one thing and one thing only: divide.
So how does this rogue cell get away with it? It's a 3-step heist, really. First, a cell mutates. That's the start. Then, it pulls off this incredible act of deception. It literally shuts down its own alarm system, these things called MHC proteins that are supposed to shout, "Hey, I'm damaged over here. Come and get me." And then, the final trick, the masterpiece. It doesn't just hide from the immune system, it actually co-opts it. It tricks it into helping it grow. It's just an unbelievably clever strategy.
So you can see, this is an incredibly complex fight happening inside our bodies. And that complexity created a massive problem for scientists. A data overload problem. I mean, how can you possibly understand the battle when you've got hundreds of different types of immune cells all doing different things at the exact same time?
For a long time, scientists were basically trying to understand this whole battlefield by looking through a tiny keyhole. They could only see about 3 proteins on a cell at once. But then, Dr. Nolan's lab had this huge technological breakthrough. Suddenly, they could see over 50 proteins at the same time. The keyhole was gone. They had a full panoramic view.
But you know, with great power comes a great problem. This amazing new view created a brand new challenge. As Dr. Nolan put it, they went from poking in the dark to facing a data deluge. There was just too much information, way more than any single human or even a whole team of human scientists could ever hope to make sense of.
So, how do you sort through a flood of data that big? This is where the story takes a turn. This is where a totally new kind of scientific partner comes into play, an AI scientist. And believe me, this wasn't just some new tool. This changed the entire scientific process itself. Dr. Nolan calls it an immunologist scientist in a box. And that is the perfect description. He's talking about something called an agentic AI. This isn't just an AI that crunches numbers. No, this is an AI that can actually reason. It can form its own hypotheses. It can basically act like a top-tier scientist. And the difference in speed and scale is it's staggering. A team of human experts might spend months, literally months, just to come up with one good hypothesis. This AI? It generated a whole network of hypotheses in 3 hours. 3. And it did that after reading and understanding 22 million scientific papers. It's just not on a human scale. And here's the really cool part. This AI is way more than just a pattern-finding machine. It's an active research partner. It doesn't just spit out ideas. It actually turns to the human scientists and says, "Okay, based on everything I've learned, here are the exact experiments you should run next to test my ideas."
So what can you actually do with a partner this powerful? Well, the first major application is already starting a revolution in something called personalized cancer treatment.
The core idea here is really simple but profound. My cancer isn't your cancer. Even if they're in the same organ, the specific biology, those little broken contracts we talked about, are unique to each person. And that means the treatment has to be unique too. It has to be tailored to you. The old one-size-fits-all approach just doesn't cut it. And this is exactly how that AI scientist is making personalized medicine a reality today. It can sift through those millions of data points to find a cancer's unique fingerprint. It can predict which drugs are most likely to work for a specific patient. It can even uncover brand new ways to attack the cancer, new targets that we never even knew were there.
Okay, so that's cancer. Now this is where the story gets really interesting.
What if you took that exact same, super rigorous, data-first scientific method and you pointed at something completely different, like, say, analyzing totally unexplained materials?
I mean, think about the challenge here. How do you analyze a material when you have absolutely no idea what it is, or where it came from, or how it was made? The only way to do it is to be completely objective. You have to let the data and only the data tell the story. No preconceived notions. So, check out this hard data from Dr. Nolan's lab. They analyzed a piece of a sample from an event back in the 1950s in Ubatuba, Brazil. Now, here on Earth, magnesium isotopes always show up in a very specific, very predictable ratio. But the ratio in this sample? It was, in Dr. Nolan's own words, way, way off.
So, naturally, they took this data to physicists and asked a simple question. What would it take to make this? How could you alter normal magnesium to get this bizarre ratio? The answer they got back is, well, it's mind-bending. They said you'd need to bombard normal magnesium with a neutron source as powerful as an atomic bomb, going off every few seconds, for 900 years.
Now let's be really clear here. This is not being presented as proof of aliens. The scientific conclusion is actually much more careful and honestly more interesting. It's proof of a technology. It's hard data that points to a manufacturing process that was far, far beyond anything publicly available in the 1950s. The data itself is the mystery. So when you put it all together, what you're seeing is a glimpse of science's next great frontier. It's this powerful new method, this incredible collaboration between human minds and AI minds. So what does that future actually look like?
What we're really talking about is a huge paradigm shift. AI is no longer just a tool, like a better calculator. It's becoming a true collaborator. Dr. Nolan pictures a future where every single scientist has an AI partner, an adjunct to their own thought process, something that can amplify their intuition and their curiosity 1,000 times over.
And that really brings us to the final question, doesn't it? We've seen how this approach can start to unravel the incredible complexities of cancer and how it can bring hard, objective data to things that have been a mystery for decades. So just imagine, what other impossible problems, what other great mysteries are we finally going to solve when every scientist has a partner like this?